let's start this second demo lecture. Like I promised last week, this week we will have a novel topic, meaning in a sense that this is something that we haven't been talking earlier. So, the topic this week is actually project planning, or how to actually manage your software project. This talk I'm going to give you is based on actual practical knowledge and experiences on software organizations and the metrics and numbers and process models and methods of working and so on are collected from different university research partners who have been working with us on different projects. So the idea today is that we'll go through the basics of how actual software development happens. What sort of resources we have, how many people or how much personnel we have, how much time it takes, what sort of process models are applied in practice. We've been talking about different things like waterfalls or Scrum and stuff like that on this course already, but how are we actually doing software? So in this big picture, I have included in almost every presentation I have given, we are talking about how things are managed, for example, here. How the project is planned, how the different milestones and schedules are set, how we observe or manage the workload. It means that how the management side of aspects happen. On almost all organizations, there's more or less the management side of process and the actual doing side or practical side of the project. So, what we plan to do and how we actually implement it. So, we've been working on this course on topics which would, in an ideal world, enable us to do software. Make excellent software with all the required features in time, in schedule, in budget, with good enough quality, and so on and so on. However, the actual success rate of software project is abysmal. This STANDISH group report, which has collected information on several software projects around the world, says that only 6% of projects happen in budget, in schedule, with the intended features, and with the required quality. 52% of the projects are challenged. Of course, you should understand from this pie diagram that it doesn't say that only 6% of every software projects actually end up in being a product or service. It means that 6% are completed with the ideal objectives, whereas half of the projects are somewhat faulty. They cost too much, they are done late or completed late, or they lack the features that were originally promised, or the quality is so poor that you actually have to spend time fixing stuff. Also, but unfortunately, this also means that 42% of all software projects fail. It means that the project fails to deliver the product, or more or less just fizzles out. So, why does this happen? How should we actually, in real life, challenge this situation? Try to ensure that we actually get what we want. So this is also a slide I have shown earlier. The problems of software development are quite, well, straightforward. The users don't understand what they need. The customers and their requirements are not understood by the developers, or the customers don't even themselves know what they want. There's constantly changing requirements, meaning that the customers want new things, or if we talk with customers who are buying your games, the trends or requirements or needs keep evolving beyond our control. The maintenance and extensions are difficult and costly. For example, we sell our software project, and then when we have to support our product, we make stupid deals which end up bankrupting our company. The projects are late simply because we run out of time, because we don't have enough personnel, because we don't have enough money, or because the customer isn't doing the reviews, or whatever reason. The schedules don't hold because the deadlines are so far and in between. There's so much time between two different deadlines that people actually get into the mindset that, okay, I don't have to hurry now, I still have 2 weeks. And after 2 weeks, we are wondering what happened, where did our time go? The quality is poor because we don't test enough. And we can't test enough because we don't have time, or we don't have money, or we don't simply know what sort of quality we need. For example, if I would ask each one of you here to write down what you think are the most important quality attributes or most important quality in an Office program. So let's say Word or PowerPoint or Excel or whatever. I'm not going to ask you to write those things down, but I can assure you that I would probably get as many different answers as there's people in this classroom. Some of you might have some similar things, like for the fact that if you type something down on keyboard, it would be nice if it shows up on your system, so sort of a user interface or responsiveness or whatever would be something, but there's wealth of different things. The quality is poor simply because it's often not thought out as thoroughly as we would like to think. There's the common description of common sense quality, or that we all share the quality attributes. Well, that's actually nonsense. The testers are focused on the quality of their own metrics, or that the cases are running. The developers are focused on unit testing results, that their code is optimized. The project manager thinks that the quality is the fact that it's available when we want it to be. And the sales representatives may say for software product that the quality for them is just whatever that we are able to deliver our customer, and they happen to pay for it. It also means that the performance is poor. The software we bought is not as fast as the one we already had, or that the software is lacking features we previously knew. And it also, in larger organizations, it also means that the projects are drifting. This is an important thing here. But drifting projects is actually one of the problems. We put people in into project and take them out from the project. We have to compete for resources. For example, test suits, or for example, this classroom, where even we have demo lectures here, there's always some people designing something for their electrical engineering courses. And that's a competition of resources that happens also in software organizations. It's a problem because it causes the schedules to not keep your schedules to drift, the personnel are drifting, there's always people leaving, there's always people coming into our projects, meaning that, well, how do we manage the information? If our lead designer decides to have a baby or decides to take another job on the other side of the planet, what sort of information will they take with them? Or how will we manage to ensure that the information that's only in the head of our developer doesn't actually walk out the door when the developer does so? Also, well, teams are not effective. We can train people, we can hire professionals and do something for that. But unfortunately, that also costs money, and that's usually the one thing that we don't have. And distribution of work is poor. Well, that's management aspect. Anyway, so this is additional thing from the requirements. Last week we were doing requirements work. So if the user doesn't understand what they want, and the users don't commit to written requirements, don't participate on reviews, don't understand the technology, or don't understand the development process, how can they then be useful to us in software project in any means? That's really interesting question, because there's a list of things that the users or target demographics or interviewed people don't actually know about. But still, they are the people we have to sell our software. So how can we actually ensure that these users can affect the design, but still keep them far enough from our project that they don't mess it up? Well, it also works the other way around. If I would be tasked to design something for children in kindergarten, it would probably be a complete disaster, since I have no idea what the kids in kindergarten want. It also works in many other ways. If a lawyer comes to talk to me about their needs for their own case management software service, I would probably need someone on my team to explain me what the actual terminology means, or in medical, Medicare, airspace engineering, all these different specialized topics. And also, finally, the design from engineer to engineer. That's one thing that can completely kill a customer product. So if you are designing games, or any software really, you don't want to do that. You need to have people with persons with people skills and domain experts who are able to design your system. So those problems with the software projects and those problems with the requirements bring us to two questions. What do the software projects actually need, and what do the software projects in real life actually have? So this is the well, sort of a idealized view on how project is managed. There's not really that many things to do. If we are running a small project and we don't have to worry about things like overseas manufacturing plants or offshore outsourcing, there's only a couple of things, really. We need to decide what we want to do. That's the statement of work. It means that someone has made the initial design and has some sort of marketing review, like the one you worked with last week, saying that, okay, this might work. Then we have project repository, where all the source code and designs and test cases and that sort of stuff is kept in safe. That's something that you don't want to really lose. And there's only a couple of, well, really small things. Meeting records, actual project plan, which we also should sometimes take a look at and see if we are going anywhere. Some sort of list of things that we need to change for our software. The software configuration here means that the version of the software that's launched or delivered to customer. and some sort of acceptance record that the customer has okayed the software in case they want to have more features and are not willing to pay for it. So basically what this diagram says, that there's only things that we actually need to focus is before project, plan what we want to do. During the project, see that the plan is actually working or that we are doing what we planned. And assessment and control. We need some sort of metrics or mechanics to know exactly where we are and where we need to be, for example, in 2 weeks or 2 months, or so on and so on. It also means that we should collect some metrics like amount of features designed or amount of things we still need to do for this iteration, like with the Scrum and the burn chart, which was mentioned on the lecture too. So these sort of things are needed to manage the project. Of course, if you are doing the development work, just doing programming tasks, then of course you don't care if we have project plan. You really don't care if we have status reports, progress status records, or any that sort of record or anything like that. Of course, if you are a programmer, you don't give rat's ass about how we assess or control our project. But since we are software developers, and we are the people who should be able to know how to manage things, at least these sort of things should be designed. So where do we save our stuff? Is it on the hard drive of person's personal iPhone or laptop, or do we have a repository? How can we access it? Do we have project plan? How do we assess that the plan is working? If the plan isn't working, why are we following it? Can we do changes to it? Why can't we do? And so on and so on. So, then, those are more or less the components or parts we have to work with. Then, the other question is, what do the software projects actually have? This information here is collected from 35 Finnish software companies in a study which spanned from 2008 to 2011. The important part here to understand is that the local organization, the amount of people you are working with in one project or in one organization, you may not be working with each and every one of them at the same time, but they are the people who you would consider your colleagues in your organization, can vary from 600 to 0. 0 means that everyone is on loan from third party, meaning that you don't actually have your home organization, but actually the median size of group is 30 people. So more or less, if you look around in this classroom, this is the amount of people you are tasked with to basically define or design or implement any software project in Finland. So this is the amount of people. We are not talking about a busload of people or stadium worth of people or testers or anything like that. All the people doing software application in medium-sized or medium-sized organization are here now in this room. Test automation is also something that you should consider. The median is 10%. Of course, the test automation is something that you go all in or basically don't have. If you are in an organization that does it, it actually may enable you to do excellent quality assurance work, or at least quality control work, because you can do regression testing simply by setting the test automation tool to run overnight. If you don't have test automation, each time you make one change to final or almost final product, you actually have to run all the test cases by hand, or select the test cases you want to run by hand. And if one larger software project may have something like 5,000 test cases for different activities or protocols or module interfaces. And this is the amount of people actually available for doing that testing work. You understand why there are problems in quality. Also, the amount of projects with any agile approach, well, this is something that actually varies. This number here is quite meaningless. If you are in a military or avionics or space industry projects, then you always go full plan driven, meaning that you are writing the documentation, you are doing the project plans, you are filing in reports on what you did today, and so on and so on. However, if you are a small organization or just doing something that's lightweight, like adding feature to existing product or doing tailoring work to sell your product to new customer, then you might as well use Scrum or something more lightweight. Because it's just easier. People aren't stupid. We aren't using rationally unified process with over 50 different roles for different people because it's fun to be bureaucratic. But on some occasions or larger organizations, we need all those people because the data mass or data flow is just so huge that it cannot be controlled. Or the project is so mission critical that if it fails, someone dies or the company goes bankrupt. So that's why you need to have the chain of evidence and be able to find the problems or the causes for problems later on. But if you are making game or just adding feature for existing product, something like a online store, then why not use Scrum? It's lightweight, it's useful enough, or agile or test-driven development or whatever, and you don't have to do the unnecessary documentation. Because one thing that actually ensures that your documentation is completely useless is requiring your people to do unnecessary documentation. If there's no actual reason for something to exist, no one pays any attention to doing that. They just do it because they were told to do so. And then everything is outdated, nothing is as defined, and you can't actually have any relevant information. So that's why in organizations, the documentation is really used only when it's necessary. If it's not something that you might need at some point, or if it's not mission critical data, then you don't actually need to record it because it just eats your small resources. Also, considering the problem with the quality assurance, the organizations more or less say that they have 70% of all the resources they would need. So if you consider that you would need 100 people for your project, or 100 people to work for something, you are in industry given 70. Or more accurately, if you think that you need 3 people to do testing or development work, you are given 2. And you just have to live with that, because that's how everyone works. You are given almost enough things, but almost on all occasions, the companies need to make profit or want to make profit, so they more or less just shave pennies off on every corner they can find. And finally, the amount of time for doing testing. So considering that if you are given 6 months to complete your product, on average, only 25% of time for project is given for quality assurance. Meaning that on 6-month project, the last 1.5 months are used to test and ensure that your product actually fulfills all the requirements. On some organizations, there's actually no dedicated time for testing. When it's working, it's kicked out the door. That's the old way of doing things. And Of course, the outlier information for something like 70% of time spent on testing might be true for something like nuclear power plants, when you really need to ensure that it works exactly as it was described. Or not only that, but it doesn't do anything surprising if there's some other problem in the system. Not only that it actually does what it says it does, but it doesn't do anything else than that on any occasion. Okay, so those are basically the most fundamental things in software projects. So, why isn't this working? Of course, it's really simple model. We specify things, we design things, we construct, we test, and we take into use. And we always get paid when one phase ends, and we are required to show something. Show our requirements, show our user interface designs, show our fully functional system before acceptance testing, or we are required that the system can actually pass the acceptance testing. So of course, like mentioned earlier, the waterfall model and way things work are problematic for more or less because it cannot react to changes. There's no change requirements, or we can't steer the project towards something. That's actually one thing that, for example, game companies really want. They have to have the power to make changes to their requirements, to their designs, everything, if they think that that's what we need. We are working with idealistic models here. We can afford projects that don't work, or products that are not necessarily good enough. But in real organizations or real software development work, we never can accept the fact that the end product isn't as good as we might have been able to do. Or if we are intentionally doing bad work, then we have already sold the support contract for that product. That's all. That's on the negative aspect. But let's consider small software corporation. If they know how to enhance their product, they will at least try to do so. And there's also always the problem that the platforms keep changing. The people change their opinions. You can't predict what people will like next summer. And of course, it expects that the bugs are easy to locate and fix. No, they aren't. They are really annoying things to fix. If you have ever played something which is using physics engine, you know that there's always something that completely messes it up. For example, in some games like The Elder Scrolls Oblivion, you can use, or was it the one before that? Well, anyway, people forgot to set the paintbrush to be affected by the physics engine, so you could basically throw paintbrush and then use it to fly on the other side of the planet because it never fell down, so you could cross oceans with that. Of course, that's a problem. But actually, it's really problematic to locate and fix all the problems in the final product. On this occasion, it would have been something like finding the class or the model and setting it so that it actually behaves with the physics enabled. But when you have on your final product something like 15,000 different objects, if you are managing that work, how would you like to click open 15,000 objects, see that everything is ticked on as they are meant to be, and close it and open the next one, and so on and so on? So that's also the management of work. That's also something that you need to take into account. You have to select the tools so that if you have to manage 15,000 different objects, then you can do something that checks or ensures that all these things are working, of course. Anyway, the iteration, the slides say that it answers to most of the problems, and it's something that actually functions in real life. And actually, the Scrum model is something that you really should get yourself familiarized with. It's actually a model that's really used in the industry. It's because it has iterations which are not comically short. You can actually do something in 2 to 4 weeks. You have a task management, you have requirements management, you have people who are defined as this one makes the decisions, and you more or less have the ability to affect how things work out. If you miss your deadmark, if you miss your milestone on this 30-day cycle, you just add new things. If something isn't working, you have to design for something for next sprint package. If you have more information based on your customer information, or if you have more some feedback, for example, from trade fair or the publisher, you can use that information to define new packages, even if they are changing things on your existing product or existing version of the software. It's also something that's quite lightweight. I said on the rational unified model, or process model, that it has something like 50 different roles. There's actually a role for person who's responsible for delivering the copies of team meeting to all the other members of the group. That's really, well, I almost said rude word, but that's really unnecessary. If we have an average of 30 people in one team, of course, why do we want to use model that applies 50 different roles? And of course, if we have to use model which tells us when and how and who delivers the copies of our meeting notes, then I'd say that there's something really problematic in your organization. People don't use documentation, people don't follow the process model if it's too heavyweight. So something like this is easy to manage. Everyone knows what they are doing. Everyone knows what the other people are doing if the daily Scrum meetings are met or kept. And still, we have sort of a illusion, at least illusion of management. If we look into the data of how actual game companies work, this again is collected from a study which we conducted, which actually does process modeling or process analysis work on game organizations. There's actually two models here. This one called pipeline here, it's actually surprisingly close to waterfall approach. We have a game idea or do brainstorming work, and then based on the best ideas, we do prototype or proof of concept work for the product. If we are able to sell this product to publisher or anyone who's, well, stupid enough or brave enough to give us money for development work, then we start to actually do that work. If we aren't able to sell it, then we throw this out and start again. At some point, someone will give us enough financial backing on this stage here that we no longer have to worry about the sales or that if it's financially feasible to do it. When we do development work, it's basically development, testing, feedback, development, testing with feedback. This loop here. When everything is done that was promised on this point or that was designed for the proof of concept, then the publisher gives their approval or the customer gives an acceptance testing, and it goes online or it's sold or it's delivered or whatever. And then there's smaller projects for maintenance, updates, bug fixes, additional content, DLC, library content. So basically what this model here does is it adds small iteration on the development and testing work, and it also takes the financial burden away from the developer, because nothing that's not financially secure enough doesn't go beyond proof of concept. And these proof of concept works here are something that we could actually do at, well, during one day with this group, more than 5 of them. It's just something that shows that we want to make a, well, dinosaur riding simulator with cowboys and something like that. And then we have a crudely animated dinosaur walking around in the jungle and the cowboy riding on the back of the dinosaur or whatever. The other way of doing actual work, if you don't have strong connections, or if you don't have publisher, or if you don't have funding, so to speak, is the iteration approach. We have an idea, we make a rough plan, we develop something, and then based on what we made, refine the design, then test it, collect feedback from anyone who is willing to test our software or review our software or give us information, what would it take to get the software published, and decide what we want to change, make rough plan, do development work, refine our design, and do testing work. Someone might add why the definition refining the design is here. It's because when we collect feedback here, we can tell the people who are giving feedback that what we have designed for future. Because if there's actually someone who is brave enough to say that, oh, I like this really much, and okay, you'll get this product launched in our app store or whatever, then if we decide that, okay, we don't want to do any work here anymore, it's good enough, it's high quality enough, we have spent enough time with this, or we just need to push this product out so that we have a sort of portfolio for future projects, then it goes to publisher, or we publish it on App Store, or we put it available on our website or whatever, try to sell it for Steam distribution. Basically meaning that if we think that it's good enough, then we go and self-publish the product. That's actually one of the most important differences here. This model works if we have publishing contract, or we have publisher, or we have already made the contract that the product will be available on Steam or somewhere else like that in, well, 6 months. And this is used when we are doing self-publishing, more or less meaning that we can do this iteration as long as we have money, or we have, well, money, or someone who is masochistic enough to keep working on the product without getting paid for the work. So, in general, this is something that we have been working on based on the international standard or international model for very small software organizations, and based on our information on how games industry works. Now, the people who we've been talking about this model have actually said that this is quite nice summary of how small software projects work. We have management here, and we have the actual implementation here. The first step is always doing the proof of concept development, and the project goes nowhere beyond that unless we have financial backing or we see that it's economically feasible to do so. Then we do development work, we have actual plans, we have someone overseeing the plan execution and doing the assessment and control, seeing that we have realistic goals in near future, and we also have metrics like money left or features missing or something like that, which we can use to see that we are actually getting things done. And when we are done with the production work, the testing work happens here actually. When we are done with the production work, we have post-production and delivery. It means that the last part is actually the quality control for acceptance testing, which is only for doing testing work, polishing it enough so that it's acceptable by the publisher or the customer or the client or the user or whoever you are working with on the project. So, of course, this isn't really accurate model in a sense that it's just blue balloons in a diagram, but these are more or less the phases or activities that actually happen in software organization. So, but it's a sort of an agile model, nevertheless. It applies iteration, it doesn't actually require or demand that much heavy documentation work. So, things mentioned here also affect how things actually happen in practice. So, where is the documentation? Or more importantly, what is the documentation? How can we ensure that our architecture will work? We might have some domain experts, for example on iPhone, or people who know enough about the Android systems or workstations that or PC architecture, knowing that it will work, but if we are unable to ensure that, how can we test the architecture? How are we going to ensure that the tools we are using, the technology we are using, the platforms we are using, the operating system we are using, or even the customer base we are aiming that are using the software platform are actually good for our product? How do we scale up? If we are doing something small scale, small mobile phone game, it's, well, good enough model. If we have like 10 people, we need one person who's the project manager who more or less knows how to handle things. But if we have more than 20 developers, we need to have some way to scale up. We need to manage what people are doing. For example, use some ticket system so that everyone sees what other people are doing and everyone knows what they should be doing. If we just send people out there, go to the repository and do something, you get, well, I almost swear again, you get nothing done. Also, if there's distributed development, that might be a problem. Also, well, mission critical, life critical efforts, meaning that if you are doing main brand, for example, developing new main version of the software, or you have some use cases or features or things that are absolutely necessary for the product to work, how can we ensure that they work? And of course, finally, we might want to do something like this or this, but if we are working on really old-fashioned company, we might end up with a command and control culture, meaning that we simply need to have the upper management making the decisions on how some programmer should be doing the source code, because of course the upper management knows better because they are paid more. Of course that won't work, but well, we've seen that in many occasions. Okay, the question about on the user or customer in the project, that the customer doesn't know what they need, are otherwise generally stupid people who doesn't understand how software is done or how anything works. How they actually affect the software project. This is again from the interviews with the software companies. So, our customer does their own conformance testing. It actually means that the customer actually affects the product in only 2 cases. They can say what they actually need, what they want. They can send feedback for future versions, but they can't say anything that's actually that has ability to affect what the actual development in the future will be. They are allowed to do a conformance testing or acceptance testing, but they are not allowed to actually meddle during the project, because the customer is given the opportunity to define their things once or periodically, like once per month or once per quarter, ability to review and give feedback on the software, and then they are just shoehorned away so that they don't bother our people doing the work. So it's actually even so that even if some of the agile models say that you always should have communication with the customer, in real commercial setting, it's actually quite unusual. The last point here is something that no one might actually expect. The direct contact to the developers is unusual, and it's actually even seen intrusive. So the client shouldn't really be able, in commercial actual setting, be able to dictate what the requirements are in our software, because they can't make decisions that will affect our financial situation. They can't say that we need this unless they are willing to pay for it. The other thing I'd also like to point out is the software quality. I said that we don't have consensus here what's good quality for Microsoft Office or any Office suite really. And this is actually something that we tested out. We had people rating these quality attributes from 1 to 5. Functional suitability, reliability, performance, operability, security, compatibility, maintainability, and transferability. How important is this to your product? And, well, first of all, only 9 people out of the 248 assessments, in only 9 occasions, someone said that, for example, maintainability is not important to a product. What it also shows is that some things that could be considered more or less the poster boys or poster girls of quality, like security or operability or performance, they actually didn't grade that well against the other things here. So this means that all these things are considered important if we just keep asking what is good quality. In fact, actually, in 35 organizations where we interviewed 4 people from the same development team, project manager or equivalent, tester or equivalent, system designer or equivalent, and programmer or equivalent. From these 35 organizations where we interviewed 4 people doing the same product, in only 1 occasion, all the 4 persons selected the same attributes, same 3 attributes, as the most important attributes for their products. In a couple of more, the 4 people, or 4 persons, were able to agree at least on 1 attribute. Of course, they weren't given the answers from other people. But that also means that even if we aren't taking something like marketing or sales or anything like that into account, even the development team doesn't actually know what is the good quality in our product unless we identify it, we communicate it, and we try to ensure that everyone knows what they should be doing. Also, There was other interesting thing on quality and testing work. So how do companies then select what they want to test on their product? Well, it's easy. There's really only two strategies. The risk-based selection, we test the things that are most expensive to fix or will cause most expensive penalties if we completely manage to screw things up. That's used on smaller companies because they are afraid that the customer will give them penalty for doing something stupid. On larger companies, which can afford being stupid, they more or less just wanted to optimize the amount of money used. So we take the design into account and try to use as minimal amount of money as needed to ensure that all the important things work. Those two are the only approaches that are actually used. And every company uses variation of this approach. So, a couple of slides before we'll go into the case description of this week. We will not have much time to work on this case here today, but we have similar deal as earlier. You have the rest of the week time to talk in your group about the case and do the work if you want to. That's the reason why we only have 2 hours of teaching events on this period, so that the other 2 hours is more or less just reserved for working on the project or working on the case descriptions or whatever. But anyway, well, the final thing I want to point out here, or one of the final things, is that, okay, so we know that the project models and the needs of actual life more or less are different than what the models are showing us. So why are we using those models? Why are we trying to enforce the ideas that we know that are inherently a bit faulty? So here's more or less a list of, well, crappy reasons why someone wants to use a model or process model which is unsuitable for their current organization. One, of course, is to professionalize the development work. It looks much nicer if we are working like a military or we are working like an engine producing something, and there's an actual saying here which is a bit crude, but it more or less summarizes the idea. It more or less goes that the random beatings will continue until work motivation improves. It means that we are trying to professionalize our organization by taking away all the personalized approaches or trying to enforce everyone into the rule of the management so that we can look professional and nice. Also, one of the other reasons is that the developers want to get more power. If we have a model, or follow a process model, it also gives the developers or the low-level people more ability to affect how things are done. So if it's in writing, they have at least some power to make decisions, and sometimes people aren't that altruistic that they just want to get more power by using these sort of a process models so they can know where to affect and what to do. Of course, if we don't actually know what we want to have, or we are run by some organization that doesn't actually know how things are done, if we can show that, okay, we are using this and this model, it gives comfort and confidence that we are doing something properly. If we are functioning like military, we are doing something right because militaries are really practical organizations. And, well, at least something like that. It also, the other point of here is that if we want to have an ISO certification or we want to show our clients that we are CMM5 level organization, that gives us legitimacy, meaning that we are a good partner because we are following the ideas of some person who sometimes said something about something without ever actually meeting anyone from our company or having no thought whatsoever on how the organization should work or what's the good way of running organizations. Similarly, as the first traffic laws were designed by a person who didn't own a car. Also, finally, it gives an audit trail, meaning that if we have some formal method of doing work, we have then some formal method of blaming other people if we manage to screw up our work. So it more or less gives an audit trail which we can use to show that it wasn't our fault, go blame someone else. So these are more or less the reasons why we end up in a real organization with the process model or documentation methods or contractual agreements, which are something that we wouldn't otherwise be doing, or we are using model which isn't really working in our organization because we want to do some permutation or some variation of all these things. We want to look more professional. We want to have audit trail to blame our customer. We want to look much more professional organization by trying to achieve ISO certification, which dictates that we have to do something that would be otherwise completely irrelevant or at best something that we could just skip or not care about, or we have someone who's really, the last point here, we have someone who's really into test-driven development, for example, or extreme programming, and sees everything as an exercise for extreme programming. This is also something that reflects the idea. So how organizations then develop themselves? They know that they don't necessarily work as good as they should, whereas with the product design, they should always try to fix all the problems they can find out. Well, the problem with the organizations is that the organizations do not tend to try out new ideas. They know that they have problems, but if these problems or inconveniences are acceptable, nothing is done for them. Only when something goes completely, catastrophically wrong, then we do process development or try to fix some problem or develop more sensible documentation or trail of information or new metrics or whatsoever, and then try to reduce the amount of inconveniences or problems. This is something that I'd like to call organization development by failure. Only when something catastrophically fails, something is done. If the inconveniences are acceptable, then actually, even if the feedback or metrics are collected, it's just bypassed. Why should we throw money or try to fix working engine when it's good enough? Well, it doesn't. It's losing money, everything is late, the quality is poor, but if someone says that it's good enough, then I guess it is good enough. And finally, on the context of this week's case, here's an example of how, for example, game development is done in 6 months. So what are the main objectives for every week? What we try to get working for that week? For example, we know that on the third week of the second month, we should have all technical infrastructure set up and be functional. And yes, I know that there's more than 4 weeks in each month, but it's simplified model. Try to live with that. So, for example, on the first month, we have initial design, which might be rejected. We do revision of the design, and it's also rejected. And on the third week, we have the revised second design, and that's something that's internally accepted. We do proof of concept, we do project planning, and then start to work with the project. This is not from any real case. This is more or less just a mix-up or mash-up of different ways we know that game developers, for example, do the software. So this is more or less the abstract version of how their deadlines have worked so far. Okay, so finally on the case description itself. So this week we are doing a design for practical project management. We have a small game development company, surprisingly, since I spent most of the time talking about games industry. We have a publisher who's interested in their new product, or they are interested at buying exclusive rights to their new product, but they want to have certain things from the company so that they would actually fund the development work. So, you and your team play the role of advisors. The Mankara Media, which is the name of the company, hasn't actually developed any sort of a method of doing software. They don't simply have any process model, or they don't have any idea on how to spend the 6 months, or how to manage testing work, or how to manage anything really. They just have 7 people sitting in one office doing testing work and goofing around, and they have managed to launch 2 products or games, one which was a minor hit in Asian markets. But now your team is tasked to draft them a project plan, give them internal schedule, deadlines, and define what sort of metrics they should have, what should be tested, and how they should test things, what they should document, draw a process model diagram, and do some other work based on these requirements that the publisher is giving the organizations. Don't overdo it. I know that this can be something as extensive as the project one, but just use the existing information from the slides I just showed you, and a couple of basic ideas from the literature, from the course archive, and other sources you might want to use to give a definition of how this Mankara Media should do their work, so that the publisher Evisoft is satisfied with their work. Start with the slides. For example, I just showed, interestingly enough, a rough schedule for 6 months of development with game development. And since we only have something like 20 minutes left, I'll also quickly show you the idea of show you the new part of Project 2. So, in this edition, you are tasked to draw a domain model, which is the class diagram with only the essential concepts, for example, orders, products, customers, how they are related to each other on this work, and make user interface description. The user interface description doesn't have to follow any actual formal approach. You just draft out the different views and user interface and all the screens and things for the use cases you selected as the essential cases for which you gave the detailed use case description here. So what sort of views the user sees, how they are supposed to be using that, and what sort of buttons and stuff there should be. And for that, you don't have any UML tool for it, because the UML doesn't do that sort of things, but use your imagination and use whatever drawing software you consider useful. But do not use the MS Paint. Or even if you try to use something that's beyond the scale of the 16 standard colors of Windows 3.1. I try to make it visually pleasing, or at least something that you as a project manager would show to your client. Let's say it that way. Okay, questions about the project work or the demo lecture, the case description. The reviews of the demo lecture go so that if you are not given any immediate feedback, then I have accepted your submission, and I'll try to add a table of given or returned demo works to the course pages, but unfortunately it's not online yet. Okay, good. Any questions? Anything to say? Call me an asshole. What?
Could you please upload the lecture, which was today?
It's
because it is there, but the slides don't match.
yes, there's a couple of slides missing from that version because I just added them, so it will be online right after this presentation. I'll put the exact same version online I just showed you. Okay, good. Anything else? Well, excellent. I'll end the recording now, and I'll stay here for a couple of minutes if you have anything other to ask.